Before we start trying to find all of our internal forces in our trusses using method of sections or method of joints, we can simplify the work we need to do by looking for zero force members. So we'll remind ourselves of the two cases we have for zero force members. The first one is an unloaded joint with two non-collinear members. Collinear just means in a straight line. So if this is my joint, this would be collinear. Anything else would be non-collinear. So this is this is non. Any other angle besides 180 degrees or 0 degrees. If it's an unloaded joint, both members are zero force. So if we look at a truss with a load of 5 kips here, pin, roller, I'll label this A, B, C, D, E. Alright, so we're looking for an unloaded joint. We're going to scan each joint of the truss looking for one of two situations. So this first one, unloaded with two non-collinear members. So this joint, I'm going to draw my reactions just so I know they're there. At this joint, I have 1, 2, 3 members plus 2 unknown forces, so I have 5 things going on there. Here I have 4, 1, 2, 3 members plus the load, so 3 unknowns plus the load. Here I have 2 members, no load. Alright, so this is going to be my case 1, so I'll come back to that. This node, this joint, I have 1, 2, 3, 4 members, so that's not 2 non-collinear. In this joint I have 1, 2 members plus a third force, so 3, not the case of 2. So let's go back to joint C. If I draw joint C using method of joints, I'm going to see force BC and force CD. There's an angle between them. If I sum my forces in the x direction, I have 2 unknowns, so I'm going to start by summing my forces in the y. And if I sum in the y, I just have force CD times sine theta equal to 0. There's no other vertical force because there's no load on the member, and there's only the y component of force CD, which is sine theta. So there's 2 options, either force CD equals 0 or sine theta equals 0, and this is only true if theta equals 0 degrees or 180 degrees, i.e. it is in a straight line or it's collinear. So if this isn't true, if it's non-collinear, then force CD must be 0. And if we sum our forces in the x direction, minus force BC minus force CD, should probably be negative, minus cos theta. Well, I've just said force CD is 0, so this whole term is 0, which means force BC is also 0. So this will always be true if it's an unloaded joint with 2 members that are not in a straight line. So we don't have to go through this statics again. We don't have to do method of joints at C. We can just say both of these are 0 force. And then what we can do is redraw the structure as if those members aren't there, and reevaluate, do we have any more members that are 0 force? And if we look here, this is 2 members, but there's a load, so it doesn't match this case. This still has 3, still has 5, still has 3. So, nope, we're good. Now we have to go through and do method of joints on this whole frame. We have another case we can look for, though. A joint with 2 collinear members, so 2 members in a straight line, and a third at any other angle. So if we have a joint and we have 2 members in a straight line, any other angle, that's our 0 force. This can be at an angle itself. Right, this is zero force. These two are collinear. So we're looking for situations like that. This could be forces or members. So if we look at that same truss we saw up above, we're just going to move the load to the tip. And if we move this load to the tip, you'll notice force BC and force CD are no longer zero force, because this is now a loaded joint at C. But we're going to scan and look for any joint that has 3 members or forces. So this joint has 1, 2, 3, 4, 5 still, because of the reactions. This joint has 3, but none of them are in a straight line, right? If I drew joint E, I would see this. None of those are in a straight line, so that's not this case. D, I have 4 members. C, I have 3, but again, nothing's collinear. But if I look at joint B, I do have that case. So if I look at joint B, I have force BD, force CD, force BC. I sum my forces in Y. The only thing I have acting Y is BD. It must be zero force. Again, this will always work, so you don't have to go through the statics. But once I find a zero force member, what I can do is either pretend it's not there, cover it up, or just not draw it the next time. So I see a structure like this. And if I go through again, this still has 1, 2, 3, 4, 5. Still has 3 non-collinear. Still has 3 non-collinear. B, I have 2, but they are collinear, so they aren't case 1. But D has 2 that are collinear and 1 at any other angle. So force AD is also 0. And it's harder to tell in this picture, but you can reorient your axes so that these are your primary axes, and you can sum your forces in Y prime to show that the only component in that axis is force AD. So let's look at some examples down below. And the easiest thing to do is just go left to right and look for these 2 cases. So this has 1, 2, 3 non-collinear. This has 1, 2, 3 collinear. That's 0. This has 1, 2, 3, 4, so nothing. 1, 2, 3, 4, nothing. 1, 2, 3 non-collinear. This is a roller, so 4. This has 3. This is collinear. This has 3 with 2 collinear. B has 1, 2, 3, 4 still. Nothing. So we've gotten rid of a few. Let's go back. This one's the same. Nothing else. This now has 3, but none of them are collinear. This one still has 4. This one still has 4. This one, though, only has 1, 2, and it's not loaded. So both of these are also 0. Right, so this one was case 2, 2, and this was 1 after removed. Force I to F. And you can keep going through all of these, try them on your own, look for 0 force members. That's not 0, it's loaded, but this is positive P. If we drew joint E, let's see, P downward, force ED, force EF, force CE, we would see that force CE is a positive P, and that is in tension, just by inspection. These are both 0. Joint D, case 1. And it's helpful to draw our reactions So we look, we can see that this is only 3 forces or members. This must be 0 force. And we can do the next 2. Alright, this is 0, 0, 0. This one's not 0, it's plus 10 because of this force. But because these 2 are 0 at joint G, you see case 1, this is 2 members, unloaded joint, so these are both also 0 force. After you get rid of the members between D and I. Last one, this one's 0, 0, 0. These are all case 2. And many people question this one. The load path for this force doesn't have to go straight down this middle joint, and it won't because there's nowhere for this force to transfer once it gets there. I have a vertical force at joint K. So I have force KD, and I have 2 horizontal ones. There's nowhere for this to go. When I sum my forces in Y, force KD must be 0. So this force transferring to this joint is actually going out through the diagonals here, because it has other members that can pick up that vertical component.